Okay, in this equation, we have a car accelerating from rest to a velocity of 26.8 meters per second, and it took 4.5 seconds. And we're asked what the acceleration is. So A equals question mark, VI, rest tells me that the initial velocity was 0. And our final velocity is 26.8 meters per second. And the time it takes is 4.5 seconds. So we go ahead and we pick the equation, which one has A, VI, VF, and T, and we get this one right there. VF, VI, A, and T are all in there. Check, 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 check. So we go ahead and it's 26.8 equals 0 plus A times 4.5. And we rearrange that. This part cancels out and we get A equals 26.8 divided by 4.5. So A equals 26.8 divided by 4.5. And the acceleration here is 26.8 divided by 4.5. The answer is 5.96 meters per second squared. Okay, so this next part, how far does the car travel? We're looking for the displacement or distance, and far can, we're not concerned with direction. And we have initial velocity of 0, final velocity of 26.8 meters per second. We have a time of 4.5 seconds. And we now have an acceleration that we can add into the mix. So we have multiple equations we can pick from. So in this one, let's go ahead and erase this one because this is the only one. We don't want that one because that one doesn't have x. This one has x. This one has x. This one has x. And so if you pull in this a, you can actually use multiple ones. But I'm going to try to use just the x, the vi, the vf, and t. X, vi, vf, and t. This last one is the one where I don't have to worry if I got the last question right. If I solved for acceleration wrong and then I used acceleration, then I'd pull this one off track too. And so x equals vi 0 plus vf, which is 26.8 over 2 times the 4.5 seconds. And we do the math. 26.8 divided by 2 equals times 4.5, and we get 60.3 meters. Okay, next question. Superman flies 20 meters north and turns around and flies 15 meters south while he's looking for Lois Lane. So let's just draw a quick picture of this. Superman flies 20 meters north, and then he turns around and flies 15 meters south, and he's looking for Lois Lane, which really doesn't mean anything. Okay, so what's this displacement? Displacement is from start to finish. What could you do if you started back here and got to the end, but instead of everything else? And so one way to think about it mathematically, you see this picture, you can kind of figure out what the answer is by having the picture, which is a good idea. But I like to say, okay, north is going to be positive, south is going to be negative, and I add the numbers together. It's called adding vectors, even though it happens to be a negative value. And that's why I usually will include a negative 15. I'm still adding the vectors, but this is really the same as subtracting 15 from it. You get your answer. Your answer will be 5 meters. And since it's positive, it's a displacement. It has to turn back into a direction. 5 meters north. And this whole time I said north was positive and south was negative, and since my answer was positive at the end, I turned it back into a displacement with north. Okay, distance flew. With distance, you add them up. You went 20 meters north, and you continued 15 more meters. So you're no longer looking from start to finish. You're just looking for what did you totally travel. And distance, you will always add it up, and you get 35 meters as your distance. So distance is a scalar. Displacement is a vector. Okay, on 15, student drops. This is going to be important. A rock from a bridge to water 16 meters below. How much time does it take for the rock to hit the water? Okay, it dropping, it doesn't say anything else. It dropping tells me two things. It's dropping, it's starting from a velocity of 0 meters per second. Its acceleration is it's falling through the air. Gravity is 10 meters per second squared downward. I'm going to draw an arrow in here. rather than having a symbol yet, because I'm going to try not to have a symbol if I don't need to. If all the directions are down, then I'm fine. I'm going to just use positive, and I know any sort of vector answer would also be down if it was positive. Okay, and so the displacement is 16 meters, and it's falling. The rock is going to fall down as well. So we're not talking about, how high he was, but where the rock is going at the end. And how much time does it take? Okay, so there is a special formula on your equation sheet. If you're using your equation sheet, t equals square root of 2 change in y over g. And that's the one you're going to use. It's a shortcut, but let's just make sure you know why we use it. VIA x and t, VIA x and t, VIA x and t. That's your equation you start with. X equals VIT plus 1/2 AT squared. Well, if VI is 0, that cancels this first part out. X equals 1/2 AT squared. At this point in time, I can get rid of the 1/2 by multiplying both sides by 2. And then I can get rid of the a by dividing both sides by a. And now I have t squared equals 2x over a. I can get rid of the squared by taking the square root of both sides. And notice how 2x over a is really the same as that. And so if I could specialize this, I go ahead and turn this into t equals square root of 2. We don't like to say x when we're dealing with the y-axis. 2y over, and there's a special, once again, a is really g. It's the same thing. And we can do our equation square root of 2 times 16 over 10. Once again, using positive values, you could also say this is negative, this is negative. You were calling down negative. It'd work itself out. So 2 times 16 equals, divided by 10. That's how I'm typing it into the calculator. And then I find the square root button, and I pull the answer back into the calculator. If you have me as your teacher, you can ask me how to do that if you don't know how to do that. 1.79 seconds is your answer. Okay, it's this one. A golf ball is dropped. Once again, it's going to be in the air. Acceleration is going to be 10 meters per second squared down. The bridge is 200 meters high. What's the final velocity of the ball right before it strikes the ground? So it being dropped, doesn't say anything else. Assume VI equals 0, and it's going to be falling through the sky at 10 meters per second squared. Once again, down, because if we contradict that and there's downs and ups, we're going to have to say one's positive, one's negative. But right now it's not, and it's not going to be here. Which you'll see, x equals 200 meters. That golf ball is going to fall down, and we're solving for VF. So we need an equation that has VIA, x, and VF. VIA, x, and VF. Nope, that doesn't have an x. VIA, x, and VF. Yeah, this is perfect. Right here is your equation. So we write down the equation, VF squared equals VI squared plus 2AX. And I'm going to go ahead and square root both sides right off the bat. VF equals square root of VI, which is 0 squared, plus 2 times 10 times x, which is 200. And we do the math, and I go ahead. I like to type things in the square root first. 2 times 10 times 200 equals, it's 4,000, but that's not the answer yet. And you take the square root and pull in the answer, and you get VF equals 63.25 meters per second. So that's how fast it would hit the ground. Okay, here's another question. Okay, when the ball is tossed up at 25 meters per second, so just a little bit about this before we start. Anytime whatever the ball is thrown up at, VF is, it's going to land at the opposite VF. At the top of the flight, V is going to be equal to 0, right there. So that could be I or F, whatever, depending on which way you're following through. The time it takes to go up to the first flight is going to be half the time, and the time it takes to come back down is half the time. And during this entire flight, the acceleration is always 10 meters per second squared down. Once again, it's always changing, and that's why you start at 20, it goes to 10, it goes to 0, it goes to negative 10 or down 10, and then it goes to down 20. And this never changed. It always changed the velocity by 10 meters per second every second the ball was in the air. Okay, so what's the velocity when heat reaches the highest point? Right there, it's going to be v equals 0 at the highest point. Once again, I'm talking about the highest point. I'm not concerned with initial or final. Just v is equal to 0 at that point. But depending on if you're solving for it, that could have been a VI or VF. What's the acceleration when it reaches the highest point? Once again, A is always 10 meters per second squared. Once again, right there, always that. What's the velocity when it returns back to level thrown? Okay, it was thrown up at 25, so it's going to be 25 meters per second down when it. And if you're answering the question, just to make sure that your teacher sees it, down should be worded rather than just an arrow. I use the arrow for the givens. What's the acceleration when it returns back to the level thrown? Once again, A equals 10 meters per second squared. This is not telling you that the ball hit the ground and stopped. But when it gets back to where it's thrown, it's still in the air. Its acceleration, once again, is always that 10 meters per second squared. Okay, let's look at some graphs. What does this graph represent? What does this graph represent? This is a position time graph. And this represents displacements and time. And if the question says, well, what does the velocity of this represent? Velocity equals x over t, or change in x over change in t. So the slope is equal to velocity. Okay, so this is probably the answer here, but if they asked you for slope, then that would be your answer. What's the displacement of the car during the first 20 seconds? Well, this is a position time graph. I can just go ahead and read off from 20 seconds. During 20 seconds, you go from here all the way down to here, and in 20 seconds, you went up 60, and then you came back down 20. So from start to finish, you went 40 forward meters. So this is what the question is really asking you for. And if you're doing it mathematically, it would be plus 60 minus 20, or plus a minus 20. Once again, I like to write it this way. Plus a minus 20. And that's going to end up equaling, just to make this a little neater, it's really the same as saying 60 minus 20, so that is going to be plus 40 meters, and then that plus means 40 meters east, or forward. Okay, during which interval is the speed the greatest? Speed is going to be the slope, but if it's speed, direction does not matter. And so therefore, it's the slope, the greatest slope, and the greatest slope to me looks like, and if I solve for it, it looks like it's going to be that first. It's going to be from time 0 to, let me go ahead and, from time 0 to time 10 seconds. Okay, in this question, what is the velocity of the object at 20 seconds? So right there at 20 seconds, I have a position time graph. I can get x's, my displacement, and I can get my time off of this. And so I'm going to take the entire interval. Since I'm trying to find that position right here, I'm going to take the entire interval, and I can go ahead and take my givens off of here. And those are my givens. This is going to be my change in t. This is going to be my change in x. And so I'm going to go ahead and I can, if I was just doing this, my velocity equals change in x over change in t. And change in x is, I could do x final minus x initial over t final minus t initial. That's just the same as saying change in. And so my final x, my displacement, is negative 40 minus my initial displacement, which was 60. My final time was 40. And my initial time was, looks like it was 15. Okay, so 40, 15, and then, so you could already have done this as 25 and this is 20, but this is what you would do, or no, that wouldn't be 20, that would be negative 100 over 40 minus 15 is going to be over 25, and you're going to get negative 4 meters per second, or you can say even better is 4 meters per second backwards. So either one would be okay. This would be the better answer. Okay, next question. What's the instantaneous velocity at 10 seconds? Okay, this is velocity, instantaneous velocity. You can just read. I was changing my velocity for the whole time. I was going backwards, and I stopped over here. And then after that, I went ahead and started speeding up again. I'm accelerating. And then at this point in time, I'm going 15 meters per second at a constant rate. So let's go ahead. Instantaneous velocity at 10 is, it is going to be right there, straight back over here. 10 meters per second. When's this object at rest? There's only one place that's at rest, and that is at the 0 meters per second. And that is from time 2 seconds to 6 seconds. When does this object have a constant velocity but not at rest? So if I go ahead and take that and I look at that, it's going 15 meters per second, the entire interval from 12 seconds to 16 seconds. Okay, so here's a little bit of math. Now we're asked for acceleration, but we're given velocities and times. So we're going to have to do a little work. A equals question mark, and we're just going to take off givens from 6 to 12 seconds. So from 6 to 12 seconds, that means we end right here. And we can get the time, and we can get the velocity. So A equals VF minus VI over T. That comes from this equation. So I'll just do it, and I'll go ahead and do it the way most students do it. VF equals VI plus AT. This is also already set up for you on your equation sheet if you're my student. VF equals, let's go ahead and write out our givens. VI is 0. VF equals 15 meters per second. Time equals, I'm going to go ahead and say that 12 minus 6, which is 6 seconds. And then I'm solving for A equals question mark. And so this one you go directly to the point. But let's go ahead, just in case you didn't. 15 equals 0 plus 8 times 6. That cancels out. A equals 15 divided by 6. A equals 2.5 meters per second squared. Okay, lastly, the displacement of the object. Once again, I have a velocity time graph. From 6 to 12 seconds, I can only take my variables off this graph. I start off with initial velocity of 0. I finish off with a final velocity of 15 meters per second. The time it takes for this interval is 12 minus 6, or 6 seconds. And I'm asked for displacement, or in this equation sheet is x. So I find an equation that has VI, VF, T, and X, and you'll find that right down here. That's the only equation that has those. X equals VI plus VF over 2 times T. Plug in my numbers, 0 plus 15 over 2 times 6. And so that's going to end up being, so 15 divided by 2 equals times 6 equals, and this is going to be 45 meters as your answer.